Our ancestors watched the skies with amazement, imagining the power of the bright objects that we now call planets.
The fact is that for as long as there have been people, we've looked at the sky, we've looked at what we see there, we've asked the question, what's the connection between that and us?
Today, new observations are revealing how the sun, planets, and moons of our solar system took shape. Scientists, like Professor Jeff Hester, are solving many of the long-standing mysteries of the formation process.
We now have answers to questions that people have asked themselves for as long as there have been people. And it changes the way that we think about ourselves.
As our nebula began to collapse under its own gravity and spin faster, a dense clump of matter formed in the center. It's called a protostar. At first, its heat was due to friction, but when the clump reached 18 million degrees Fahrenheit, nuclear fusion kicked in. 4.5 billion years ago, our star was born. Hydrogen atoms fuse together to form helium, and in the process, release photons. It's the first light made by our sun, and it will keep on shining for 4 billion years. A vast nuclear furnace, nearly 1 million miles across. From a distance, this process seems almost peaceful, with the sun's power gently radiating out into the early solar system.
There was all sorts of activity going on. Things were changing rapidly, violence, explosions, intense radiation. We had a pretty spectacular origin, I think.
Comets aren't the only source of material from the early solar system. Meteorites are ancient too, and they have one huge advantage. They come to us.
The amazing thing is that any time you pick up a meteorite, with very few exceptions, you take it into the laboratory, you date it, the answer is it's 4.5 billion years old. 4.5 billion years old. These are pieces of the early solar system. And so here you have in your hand a piece of something very substantial that connects you and connects our existence and connects the history that brought us to be with this larger universe.
After extensive analysis, Hester's team discover unstable isotopes of iron-60 locked inside the meteorites. It's totally unexpected. Iron-60 decays relatively fast, so it must have come from close by. If it came from any great distance, it would have had time to decay into a different isotope before the meteorite could trap it. Only a supernova can make iron-60. So there must have been an active supernova close to the infant sun.
To come along with a piece of hard evidence that says that nope, early sun, early solar system, we're in a violent environment near a massive star, experienced a nearby supernova, it was surprising. We realized that this is going to change the way that people think about what goes on. This is going to change our understanding of the origins of the solar system.
Despite the violent forces being unleashed, our solar system may have formed right alongside a supernova.
These are exquisitely violent events, and they reshape everything around them.